This is an A-level further statistics 1 question on quality of tests. Information was collected about accidents on the Cepron bypass. It was found that the number of accidents per month could be modelled by a Poisson distribution with mean 2.5. Following some work on the bypass, the number of accidents during a series of 3 months periods were recorded. The data were used to test whether or not there was a change in the mean number of accidents per month. Part A, stating your hypothesis clearly and using a 5% level of significance, find a critical region for this test. You should state the probability in each tail. Okay, I'm going to start by stating what my random variable is. Now you don't have to do this, this is optional, but I like to do this. So here it's going to be the number of, and it's always going to be the number of something. So the number of accidents, and we're measuring it in a 3 month period. In a 3 month period, and my random variable x is being modelled by a Poisson distribution with a mean of 2.5. Now that's per month, and because I'm looking at the number of accidents in a 3 month period, I'm going to times that by 3, and so we've got a Poisson distribution and we're using a mean of 7.5. So we'll start with H0 and H1. So H0, the mean number in a 3 month period is going to be 7.5. H1, we're looking to see whether the number of accidents, there was a change in the number of accidents. So it'll be lambda is not equal to 7.5. So we're looking at a 2-tail test here. So I'm going to be looking for probabilities that are 2.5% in each tail, and they need to be less than 2.5%. Now the easiest way to do this, I think, is just to use the table. So if I go to the tables and look for the largest probability that's less than 2.5%, I get the probability of x less than or equal to 2, and that one is equal to 0.0203. The next one's bigger than the 2.5%, so that's going to be my lower value. Now for my upper value, I'm trying to find a value of x such that the probability of x greater than or equal to x is going to be less than 2.5%. So I'll just rearrange this and solve this equation. So that's the probability, or 1 minus, so when it's greater than or equal to x, that's the same as 1 minus the probability that x is less than or equal to x minus 1. Now if you're not sure about what to put here, think about what to do if this was numbers. So if this was the probability that x is greater than or equal to 7, the way that you do that is the probability that x is less than or equal to 6, one less than this. And we want that to be less than 0.025. Then we'll take away 1 from both sides. So let's do that. So we'll have negative probability x less than or equal to x minus 1 is less than, and we'll get negative 0.975. We get rid of the negatives, which means we need to flip the sign. So the probability x is less than or equal to x minus 1 is going to be greater than 0.975. So now we can work out what x minus 1 is in the table by looking for the first value that's greater than 0.975, and that's 13. So that gives us x is equal to 14. So 2, and we don't write it down, so the 14 there and the 2 here, those are the critical values. I want the critical region, so let's write that down. critical region is when x is less than or equal to 2 and when x is greater than or equal to 14. Part B, we want to state the probability of a type 1 error using this test. So a reminder, the probability of a type 1 error is the probability that you reject H0 given that H0 is true. Now, the probability that we reject H0, this is the size of the rejection region, or the probability of being in the rejection region. Now, from part A, the probability that x is less than or equal to 2 is 0.0203, this is from the formula book. And the probability that x is greater than or equal to 14 is 1 minus the probability it's less than or equal to 13, which gives us 0.0216. So the probability of landing in the rejection region when H0 is true, that's when lambda was 7.5, is 0.0203 plus 0.0216. We'll add the two together and we get 0.0419. Okay, so the probability of a type 1 error is just over 4%. Data from the series of 3-month periods are recorded for 2 years. Part C, find a probability that at least 2 of these 3-month periods give a significant result. So there's a couple of things going on here. We've got a sample of these 3-month periods recorded for 2 years. Okay, so that means we've got like 8 samples of data, and whenever I'm thinking of samples, I'm thinking of binomial to do this part of the question. I need to find a probability that in at least 2 of these 3-month periods, so there's another clue, it's binomial, gives a significant result. Now what does that mean? A significant result is what we get when we reject H0. That's a significant result. One of the wordings you can use when you talk about accepting or rejecting H0 is talking about how something is significant or not significant. So the first thing I'm going to do is to define my random variable. You don't need to do this, it's optional. I'm going to say let y equal the number of, so it's always the number of something, the number of 3-month periods, not 3-month periods with a significant result. With a significant result. Now this random variable that I've called y is a binomial distribution. I've got 8 sets of data, so my sample size is 8, and the probability I'm going to get a significant result is going to be this 0.0419 when I reject H0. And what I want to do is I want to find the probability when y is at least 2, so greater than or equal to 2, which means it's 1 minus the probability that y is less than or equal to 1. So we'll work out this. Right, so this is 1 minus, on my calculator I've got 0.958462. Okay, so let's work that out. And that comes out as 0.041537 and so on. I'll give an answer to 3 significant figures. So that's 0.0415 and that's 3 significant figures. Okay. Now it says, given that the number of accidents per month on the bypass after the work is completed is actually 2.1 per month, part D, find the probability of a type 2 error for the test in part A. Now the test in part A was for a 3-month period, and we've got the number of accidents per month is 2.1. So we need to be careful that we make sure that we scale it up to a 3-month period. So first of all, the probability of a type 2 error is the probability that we accept H0 given that H0 is false. Right, so what we want here is the acceptance region. We've got the rejection region, so the acceptance region is going to be between those two. So when x is greater than or equal to 3 or greater than 2, and when it's less than or equal to 13, or when it's less than 14, given that lambda is equal to 2.1 times by 3, so 6.3. So I'll just put here where that came from, the 2.1 per month times by 3, because we're dealing with a 3-month time scale. Right, so I'll have to split this calculation up, unless you've got like a graphic calculator where you can work out these probabilities between two things. So it's going to be the probability x is less than or equal to 13, and I want to subtract from that the probabilities that I don't want, which is going to be the probability that x is less than or equal to 2. Okay, working out the first probability, we got 0.9945147. Subtract the probability when it's less than or equal to 2, which is 0.049846. Let's see what that is. And that's 0.94466. Okay, again, 3 significant figures, so I'll go for 0.945. Okay, so that's the probability of this type 2 error. And I'll just put down here that I've rounded this to 3 significant figures.